Guys, welcome back to another video here from the Off-Grid Garage late night show. Today with the video I want to show you how to control your Victron system from the SEPLOS BMS. And thank you again for your many comments under my last video where I talked about the concerns I have with the SEPLOS BMS and showed you the settings which I found not optimal. And some of you have left a comment under my last video saying, Andy, you got this totally wrong here. The SEPLOS is not controlling the Victron system. The Victron system is still using the settings and charging the battery here. And the SEPLOS BMS is only delivering the data to the Victron system. And this is not quite true actually, because as soon as you connect any smart battery to the Victron system, this whole charging algorithm here turns off. And while the solar charge controller still charges your battery, of course, it doesn't use its internal algorithm anymore. There's no bulk, there's no float, there's no absorption time, nothing like this. It only reads the parameters from the SEPLOS BMS and acts accordingly. And I also want to show you the settings you need to change in the BMS to control your Victron system. And this is all a bit weird, so it took me a while to find out how this all works together and which parameters we need to change in the BMS to make this happen. And in the first test, I have only connected the bottom battery. I've disconnected the top one. I actually just figured we could leave the batteries here physically connected because we're not charging or discharging the battery. It is only about the BMS. So I have completely isolated the bottom BMS now here, the 10E. Took down all the dip switches to 0 and left the CAN communication port connected. So only the BMS of the bottom battery is reporting to the Victron system, not the top one anymore. There's no communication in between the two batteries and the BMSs anymore. And here you can see this, it shows only one battery online and everything is related to battery number 1 only, one battery pack. So, and we are now connected to the remote console of the SPET calibration center. And you can see all the devices we have connected. There's our SEPLOS BMS and there's also the pool fence solar charge controller. So let's have a quick look in the pool fence solar charge controller, all the way down to network operations. And here you can see that the mode settings are saying external control and BMS. So as soon as the Victron system detects a BMS, it goes into external control for all its chargers. These are the solar charge controllers you have connected, as well as the Multiplus or Quattro with internal charger. They are all listening to the BMS of your SEPLOS battery then. Okay, let's go back here into the SEPLOS BMS and let's go all the way down to parameters. Parameters, this is the important settings which are getting transmitted from the BMS to the Victron system, and then the Victron system acts accordingly to these settings. These are the 3 important settings the BMS constantly sends to the Victron system. So we've got the charge voltage limit, CVL, the charge current limit, and the discharge current limit. Again, this is all controlled by the BMS. But how do you change these parameters if you want to charge a bit higher or want to have different settings for your charge current? Because there's no way to change this here in the Victron system. It is not controlled by Victron anymore. Okay, so let's go into our smart BMS. Log in, connect. Okay, it says single down here, so it's only a single BMS connected. We go into the parameters. And I want to show you which settings you have to change the parameters in the Victron system as well. So the Victron system then follows the parameters from the SEPLOS BMS, because this is all external controlled now. So the most obvious is, of course, the charge voltage limit. And this is set to 55.2 volts. And we can see this here. This is our total voltage over voltage protection. So if we want to change this, we click on Edit, put in the password, and then change the value to, say, 55 volts. Save this, and you watch the parameters in the Victron system. Once I click Save, they change to 55 volts. So this is how you control the maximum charge voltage you have in your system then. The BMS will request this as the maximum charge voltage in your system. And the MPPT controllers or your multiplus or quattro charger will follow this request. Not what you have set in your solar charge controllers. It will completely ignore these settings. Okay, I'll change this back to 55.2. And we can see here in the remote console, bang, 55.2. It changes the parameters accordingly very quickly. So this is a very obvious and easy to find setting. So how about the charge current limit here? The CCL. So this is the maximum charge we are allowing into the battery. And you want to ask, well, why do you want to limit the charge current? You want to charge as much as possible into your battery. Well, if you have a lead acid battery, an AGM battery, or any flooded battery still, and you have a very large solar array system, you cannot just charge your lead acid batteries with an unlimited current. Usually these batteries are charged with 0.2 C only. And depending on the size of your battery bank, then you have to limit the charge current. Otherwise you will overcharge, you will damage your lead acid batteries. This is different with lithium batteries, but again, I have the same issue here. My solar array is now in summertime far too large for these batteries, and the battery shelf is not designed to take 270 amps. So I have actually limited this current into the battery shelf to 200 amps only, because this is something which can be safely transmitted into the batteries. Okay, so to change the charge current limit, CCL, in your Victron system, okay, I had to clear this alarm first because the CCL, the charge current limit, was set to 10 amps. As soon as an alarm occurs, the BMS requests only 10 amps of charging current. So this is all cleared now. So we can see we've got a limit of 50 amps going into the battery then. This is our limit we have set. And to find this parameter, we have to go all the way down to overcurrent. And the important setting here is the charging overcurrent warning. You can see it sits at 100 amps. So why does it show only 50 amps there? So, and I found out that it is exactly half of what we are setting in the BMS. So if you set 100 amps, the charge current limit will be 50 amps. If you set 200 amps in the BMS, your charge current will be 100 amps. Why that is, I don't know. 120 amps divided by 2 is 60 amps. So we'll see the charge current limit will go up to 60 amps. Once we save this parameter, success, and now you can see the charge current limit is increasing from 50 to 60 amps. So this is how you set the charge current limit. Okay, next parameter is the discharge current limit. So obviously this is the discharge overcurrent warning then, right? And here it is a different formula. Well, for charging, it is half the current we are setting in the BMS. For discharging, it is the exact value minus 10 amps. Again, I don't know why that is, but you can see I have set 150 amps here in the BMS, and the discharge current limit, DCL, shows 140 amps only in the Victron system. So if you want to set 100 amps as discharge current, obviously you have to add these 10 amps. So you set this one to negative 110, click on save, and we can see it changed in the Victron system immediately to 100 amps. So it's always 10 amps more in the BMS what you have to set than what you actually want the battery to be discharged with. I don't make this shit up, guys. This is just what SEPLOS came up with. These are the parameters and formulas you need to know to change the parameters in the BMS, to change the settings actually in the Victron system so they can follow the request from the BMS. So what happens now if we reconnect the second battery again? And the only thing we need to do is plug in our RS485 cable again, which goes to our slave battery here, and set dip switch number 5. So we've got a master and the slave for CAN communication. And as you have seen, the parameters have changed accordingly in the Victron system now. And now everything is a bit different again. So obviously the charge voltage limit is not changing. This is still our over voltage, what is it called? Total voltage over voltage protection. 55.2 is still the same parameter, same formula, it's 1-to-1. Makes sense. But you can see the charge current limit has now doubled Because remember, it was the 120 amps we have set here for the charging overcurrent warning divided by 2. And then we had 60 amps. But now we have 2 batteries in parallel, and the BMS knows that because we set the dip switches accordingly and connect the other one via RS485. It actually doubles this because it thinks, well, every battery can deliver these 60 amps, so make it 120, right? So, and interestingly here is, if you connect now to the slave battery via the computer and change the same setting in there, it won't have any effect in the Victron system. So only the master BMS determines what is being reported to the Victron system. All the settings in the slave battery will be completely ignored. So if you want a maximum charge current of 200 amps, you need to put, so we can set 200 amps in the parameter, because 200 divided by 2 times 2, because 2 batteries, is 200, right? So if we save this one, we will see it increasing to 200 amps now. Oh no. Maybe one of my other parameters. See, now because our charge overcurrent protection is set on 160 amps, but we have set the warning to 200 amps, which doesn't make sense. It doesn't save the parameters then, because this is not making any sense. So we need to set this one equal or higher than the actual warning. So I'll set this one to 210 amps. So we can save both parameters if we get a success. Yep. We can see now the charging current limit is increasing in the Victron system. So here it is, charging overcurrent warning divided by 2. That's what it was for one BMS. And now we've got 2 BMSs, so it's times 2 again. And as you could see, the discharge current limit increased as well. And this was our discharge overcurrent warning, minus 10 amps. And again here it is then times 2, because we've got 2 batteries in parallel now. So as you can see, 110 minus 10 is 100 times 2 makes 200 amps, and this is exactly what the Victron system shows. So if I change this parameter and set this one to 100, for example, it's 100 minus 10 is 90 times 2 is 180. So the discharge current limit in the Victron system should change to 180 as soon as I save this one. Bang, 180. So that's how you change the parameters in the Victron system, and the Victron system will only follow what the BMS requests or demands or wants. I link all these formulas on the website. There's the link down under the video for that. But I want to show you something else now, because these settings are only valid for the 10E BMS from SEPLOS. And as you know, the other BMS is a 10C. It's one of the older BMSs from SEPLOS. And the parameters and formulas are a bit different, unfortunately. Okay, so I want to show you the slave battery as well, the BMS, which is the 10C. So what we're going to do, we disconnect the link to the master and take out the can and plug this in directly into our smaller battery and take the dip switch 1 down. So this is now the only BMS connected to the system. So we are now connected via the battery monitor software from the computer to the older BMS from SEPLOS, the 10C BMS. And you can see here in the parameters of the Victron system, the maximum charge voltage has changed to 56.3 volts all of a sudden, right? And if we have a look in the parameters of this BMS, we can find that our total voltage over voltage protection, which was the setting for the other BMS to change this parameter here in the Victron system, is set to 56.5 volts. But we are showing 56.3 volts. So let's change this one to 55.2 volts. Set, success. And as you can see, exactly, it doesn't change the parameter in the Victron system. And I have changed all the other parameters as well. And to be honest, I cannot find the right parameter to change the CVL in the Victron system. Regardless which voltage parameter I change here, it is always sitting on 56.3 volts. We are connected to the single BMS. This is the 10C. Again, this is the 10C BMS running firmware 2.8. and I'm unable to change the parameters for the Victron system. Regardless what I change here, in which combination, doesn't matter. It always sits on 56.3 volts, regardless. So I don't know. So I'm totally reliant on you now. If you have set this up with a 10C BMS running firmware 2.8, what is the parameter I need to change here to change the CVL, the charge voltage limit as well? I have no idea. I couldn't figure it out. Okay, let's move on from this disaster. A little bit further down. Here are my amp settings. So we want to change the charge current limit CCL. Sits on 100 amps at the moment. And charge current limit, where is it? Where's the charge current limit? Charge overcurrent warning, right? That's the one. Sits on 110. So it looks like we need to set it 10 amps higher. Fucking shit, was denn das für ein Kack jetzt hier? Oh, come on. Oh, fucking shit hier. Jetzt ist das ganze Scheißding hier gecrashed. Warum ist denn jetzt diese Kack-Software zugegangen, ey? Verdammte Dreckscheiße hoch 10. Kann doch nicht sein, ey. Was ist denn das für ein Scheiß, Alter? Ich mich nochmal einloggen, na klar. Verdammte, erbärmliche Hühnerkacke. Let's click in here. So if we change this one to, say, 100 amps in the settings of the BMS and save this one, let's see if it changes to 90 then. It does, it does. So it's the same formula as for the other BMS, but different. Because if you remember, you may not remember because it's very confusing. For the other BMS, it was for the discharge current limit. We have to set the parameters, and then -10 was what was reported to the Victron system. Here it is for the charge current limit. So if this is not stupid to change these formulas from one BMS to another one, set all, then it goes to 80 here in the Victron, or 70, sorry. Yeah, 80 amps -10 is 70 amps in the Victron system. So it is totally nuts, right? And the discharge current limit in the Victron system sits on 90. You have to find the discharge overcurrent warning. This sits on 100 amps. So it looks like they're using the same formula for both here in this older BMS. So if I set this one to 110 amps, set all, yep, success. And this one changes to 100 amps in the Victron system. So it's the same formula here for charging and discharging, which makes sense. But it's a different formula for the 10C BMS. For whatever reason, we don't know. It is what it is. Let's leave this running and go back to our battery here. And now I wanna set this one here as my master BMS. Sometimes it needs 2 attempts or 3 or 4 attempts to actually save the parameter. No. Is there another freaking... No. Ah. We now have the limitation again. Well, I cannot show you this at all because I cannot connect to the master BMS anymore via the software. Remember that we cannot connect to the master BMS via the software when we have several batteries in parallel. That was like the limitation, and SEPLOS actually recommended to use the 10E as a master BMS because we can use Bluetooth to connect to it. But it's not possible with this BMS, so I cannot show you the parameters, how they change when we have 2 batteries in parallel. Well, we can see a bit of change here already in the... Oh, you can see the screen recording. Stupid. I'll set up the master-slave configuration again. And we could see the parameters jumping. Basically, they doubled, right? They doubled. So it's always what you set in the settings of the BMS, -10 times 2 or times 3 if you have 3 batteries in parallel. There's a certain consistent inconsistency here, but I think we got all the information now together. This is all very complicated, but you see, you change the parameters in the BMS and the Victron system follows. So it's not like the Victron system is in charge here and to deal with your battery. No, it's waiting for the parameters coming from the BMSs. Yeah, and this is the limitation. We cannot connect to the master BMS via RS485 with the old BMS anymore. Okay, that's fine. We figured it out. We've got all the information together. So I put this all here on the screen, but it will be on my website as well, which I linked down under the video, as I said. So you can always go to the website and see how the parameters are being calculated and what parameters you have to change in your BMS to make this work with the Victron system. Okay guys, so far this very complicated video from tonight. I mean, you have to change the, what is it called? Discharge overcurrent warning. It's a warning parameter to change the setting in the Victron system. I'm just showing you how it works. I have not invented this. I have not designed this. I have not programmed this. This is not German engineering. Anyway, guys, regardless if you have the older 10C or the newer 10E BMS, you know which parameters to change now to set your Victron system accordingly. And tomorrow, in tomorrow's video, when the sun is back, it's a bit hard to do at the moment. We want to see this in action here. Want to actually see if the BMS limits the current then going into the battery, because we can throttle this down to 1, 2, 3, 4, 5 amps. So we can actually see this in action here, and I'm very keen to test this one out. And what I thought, how does it work with the discharge current limit? How does the BMS limits the current? How does the BMS tells the Victron system to limit the discharge current? Because the discharge current is solely dependent on your load. And you cannot tell the system, well, can you turn off the light there and the washing machine there so we have less load on the system? That's not possible. You can turn off the load or leave the load on. That's all. So does this mean the BMS would cut off your load altogether if we reach this limit? This is what I want to try tomorrow. And guys, we've got the perfect setup here. We've got the two batteries in parallel. We've got the Victron system. We've got the XIA inverter. We've got an air conditioner we can run. And we can really see what is going on if we set all these limits and parameters for the Victron system. How does it react? How does it work? What is it doing? I'm very excited for tomorrow, guys. I'm very excited. I want to see this in action, right? Okay guys, I think so far this little tutorial or workshop tonight here showing you all the parameters you need to change in the old 10C BMS and also in the new 10E BMS from SEPLOS. And this has then an effect on the Victron system, and the charger will act accordingly to the request of the SEPLOS BMS. Again, link is down below. As always guys, thank you so much for watching. Thanks for all your amazing support, all your very generous donations. Thanks for all your emails. I'm reading all your emails. I'm not able to reply to all of them, unfortunately. There are far too many. Was it on Sunday or Saturday? I received 35 emails a day. 35 emails. I guess until the next video tomorrow morning, guys, you stay charged, stay safe, and have a good night's sleep. See you then. Bye-bye.